Today I'm going to talk about matter, which is one of the most essential topics of SAT 2 chemistry. So what is matter? Matter is everything around us that has mass and volume. Mass can be defined as the amount of matter that something is made up of, and volume can be defined as the amount of space that's taken up by an object. So I want to further talk about mass and stress the fact that mass is a property that does not change. This is one of the most important facts about mass that I want you guys to keep in mind. Now, a lot of people think that there is no difference between mass and weight. However, there is. So mass and weight are two different things. So they're not the same, but they are in fact relevant. So weight can be expressed as the product of mass and gravity. To give you an example, there is a person named Kelly. She has a mass of 50 kilograms. Now, on Earth, her weight is, for instance, 110 pounds. However, when she goes to the moon, her weight becomes 43 pounds. Here you can see that even though Kelly's mass stays constant, whether or not she's on the Earth or on the moon, her weight changes. That being said, if mass is being held constant, yet weight is being changed, that means that the gravity of the Earth and the gravity of the moon are different in order for the weight to be changed. So I want to introduce one more property that involves mass, which is density. Density can be defined as mass over volume. So let's say you have 10 grams of water here and then 10 grams of water here. Now, with the second portion, you put in the freezer, so it becomes ice. So density of water is actually not the same as the density of ice. Density can be expressed as this rho, the Greek alphabet. That tells us that if the density is being changed when going from water, liquid water to ice, even though we started off with the same mass, that tells us that the volume is being changed. In other words, volume is a key factor for changing the density. Now I'm going to talk about the three states of matter. So matter occurs in three states: solid, liquid, and gas. So as you can see from this table, a solid has both a definite size and a definite shape. A liquid has a definite volume, but the shape of the liquid is determined by its container. A gas has neither a definite shape nor a definite volume. So these three states of matter can often be changed by the addition or subtraction of heat energy. And one example is ice, changing to liquid water, and then changing into steam. Now moving on to the composition of matter. Matter can be subdivided into two categories: mixtures and pure substances. Now, before I talk about these two categories, I want to first introduce the term atom. So atoms are considered to be the basic building blocks of matter that cannot be easily created nor destroyed. So it literally means that it's the smallest possible piece of something. Let's move on to pure substances. So pure substances can be subdivided into the smallest particle that has the same properties of that substance. Now, there are two main categories of pure substances: compounds and elements. So the composition of an element is made up of one kind of atom. That being said, all parts are the same throughout. Unlike elements, a compound is made up of two or more kinds of atoms. Although they are made up of two or more kinds of atoms, the composition is definite and all parts react the same. However, please remember that the properties of the compound are distinct and different from the properties of the individual elements that are combined in its makeup. Now, let's talk about mixtures, another category of matter. So mixtures are actually made up of two or more substances. Also, they can vary in their compositions. Now, mixtures can be divided into two subcategories, which are homogeneous and heterogeneous mixtures. So, homogeneous mixtures have a uniform composition throughout the mixture, while heterogeneous mixtures have a mixed composition, which may vary from point to point. So once again, this following chart shows a classification scheme for matter. Matter can be divided into mixtures and pure substances. The way you tell if it's a mixture or a pure substance is asking yourself if it can be physically separated. If it can be physically separated, then it's a mixture. If it cannot be physically separated, then it's a pure substance. Now, when you take a mixture, you can tell if the mixture is homogeneous or heterogeneous by seeing if the properties are uniform throughout the mixture. If they are, then it's homogeneous. If they aren't, then it's heterogeneous. Some examples of homogeneous mixtures include air and sugar and water. Some examples of heterogeneous mixtures include blood and sand and water. Now, taking a pure substance, if the pure substance can be decomposed chemically, then it's a compound. If it cannot be further decomposed, then it's an element. Now, some examples of an element include oxygen, hydrogen, and all the other elements that can be found on the periodic table. Now, one example of a compound is water. So, as you already know, water contains two atoms of hydrogen and one atom of oxygen. So, it's made up of oxygen and hydrogen, which is more than one kind of atom. Now, I'm going to talk about the differences between chemical and physical properties. So, physical properties of matter are the properties that can usually be observed with our senses. So, some examples include color, taste, odor, melting point, and density. Now, chemical properties are those properties that can be observed by changing the identity of the substance. So they often result from reacting with other substances, which indicates that it involves changes with chemical reactions that alter bonds. So remember that it's related to changes within chemical reactions. Some examples include flammability and reactivity. So matter undergoes changes, and those changes can be classified as either physical or chemical. Generally speaking, physical change doesn't alter the identity of the substance, but chemical change does. For physical change, there is no new substance that's being formed. So let me give you some examples. Breaking glass, crumbling cookies, paper ripping. Those are all physical changes where there is no new substance being formed. So the composition does not change. Now, for a chemical change, there is a new substance that's being formed. For instance, baking cookies, burning a candle, frying an egg. So those are some examples of chemical changes. Now I'm going to talk about conservation of mass. The law of conservation of matter says that matter cannot be created or destroyed in a chemical reaction. To give you an example, when you combined reactant A and B and produce product C, let's say that the mass of A was 50 grams and the mass of B was 20 grams. That being said, according to the law of conservation of matter, the mass of C must be 70 grams. Why? Because matter cannot be created nor destroyed. Now, let me give you another example. Let's say you take A and B once again, combine them, and you produce more than one product. That being said, the mass of reactant A and the mass of reactant B should be equal to the sum of the mass of product C and the mass of product D. So this wraps up the concept of matter. Thank you for watching. Please stay tuned for the next video. Thank you.